Alright, welcome back, guys. We're on day 2 of our topology where we're going to configure the office network side. In the last video, we configured our data center where we configured the point-to-points between our data center core and our spine switches. We verified that we got neighborships and tested connectivity between our layer 3 routers. We configured our spine switches on the management and server VLAN. We configured a port channel and configured HSRP between the spine switches, and then we tested to verify that our DHCP server can ping all the way to the office core. So today we are going to pick up on the office core side and do exactly as we did on the data center to the office. And by the end of this video, in hopes we should see that our admin, user, and printer devices can receive DHCP addresses from the DHCP server in the data center. So we're going to kick it off with the office core switch. In the day 0 config, we configured a EIGRP point-to-point between the core switch and the campus router. So we just need to start with configuring the point-to-points between the office core switch and the distribution switches. So we're going to jump into, let's see what interfaces these are. Gig 112 and Gig 113. So let's just start off by doing Gig 112, interface Gig 112. Gotta send that no switch port config to turn it into a routed port. Send an IP address of 10.10.0.9 with a /30 mask. And then we're gonna jump into interface Gig 113. Do command recall. All we're gonna do is just change that 9 to a 13. Once again, we got to do no switch port. That's my mistake. Send that IP again. Now let's jump back to global config mode and let's get into router configuration mode for EIGRP AS10. Let's advertise those networks that we just built for 112, 113. So network 10.10.0.8, the .3 wildcard. Do command recall. We're going to go jump over to the 8, change it to a 12, command recall. Now, in the previous videos, when we were building out EIGRP, we ensured that we made all interfaces passive by default to prevent rogue routers being attached to the network and injecting routes into the network, bad routes into the network. So we're going to go and do that in the office core as well. We did it to our Gig 111 interface going to the campus router, but now that we're configuring the downstream interfaces down to the distribution switches, we're going to go and add those in as well. So let's do no passive interface Gig 1112, command recall and do 3. Alright, so that should settle it for the office core. Let's jump into distro switch 1. So we got to get these guys caught up because we haven't done anything with them. We're going to send a no IP domain lookup command and then no logging console. Let's give it a host name of DS1 for distro switch 1. Alright, what interfaces are we working with? We got 111's the uplink. We have, this should be 103, 102. Is going to be our future port channels, and I think this is 1024 as our downlink. So we're just going to focus on Gig 111 right now. So interface Gig 111, send that no switch port command, and then configure the other side of the point-to-point. So IP add 10.10.0.10 with a /30 mask. And let's back out. Let's enable our routing so we can do EIGRP. We'll do router EIGRP 10. Define our network that we want to advertise. So 10.10.0.8. The .3 wildcard. Passive interface default. And we're going to explicitly say that we're going to make Gig 111 no passive. No passive interface Gig 111. Back on now, let's do show IP EIGRP interfaces. You got a peer. As I said in the previous videos, you got a peer, you got a neighbor. You got a neighbor, you got a peer. Okay. So our neighbor is 10.0 to, or 10.10.0.9. We should effectively be able to ping all the way out to the DHCP server, which is 10.10.10.10. So let's ping 10.10.10.10. And we can ping it. All right, so that's all we're going to do for the moment with DS1. Let's jump on over to DS2. Get it caught up. No IP domain lookup. No logging. Console. Host DS2. Let's go ahead and enable IP routing while we're here. And jump into gig 111, no switch port, IP add 10.10.0. We got 13.14. /30 mask. Back to global config. Jump into router configuration mode for EIGRP. Advertise that network of 10.10.0.12 with a .3 wildcard. No passive interface default. No passive gig 111. All right, let's check our neighborships. Show IP EIGRP interface. Got up here. So I'm not gonna worry about checking the neighborship because I said many times over by now. If you got a peer, you got a neighbor. If you got a neighbor, you got a peer. Just two ways of skin the cat. So we're gonna ping the DHCP server 10.10.10.10. We can ping it. All right. So next thing we're gonna do is we're gonna build our port channel between our two ports right here on 102 and 103. Right now they're dynamically trunking, but we are going to send the range command to those two ports, and we're going to configure them as a static trunk. So switch port mode trunk. And then we're going to do channel group 1. Gotta finish the command, don't I? Mode. And on the other side we did desirable. We're going to do the same on this side. Desirable. Right mem, and let's jump over to DS1. Do the same deal. Interface range gig 102 to 3. Switch port mode trunk, and then channel group 1 mode desirable. Let spanning tree do its thing to recalculate. And in the meantime, what we're going to go ahead and do, well, let's go and configure a trunk on 1024. Switch port mode trunk, that's kind of like low-hanging fruit. Might as well knock that out. Same thing with DS2. Interface gig 1024. Switch port mode trunk. That be that. Okay, so with our office network, we now have 4 VLANs we have to configure. We have the management, user, printers, and the admin VLANs. We're going to start with management and work our way down the list that we have here on our office network. So let's go ahead and just create the VLAN. So we're on DS1, by the way. So we're going to create VLAN 5, name it management. And then VLAN was that 110 for users, name it users. VLAN 120 for printers, name it printers. You don't have to do all caps, I'm just doing it because. VLAN 100, name admin, or admins. Okay, now that we create our VLANs, let's go and create our SVIs. I'm gonna kind of do, so we're gonna do HSRP as well, but the way that I'm gonna do this is I'm just gonna like hop it back and forth where like management on DS1 is gonna be active, and then users is gonna be standby on DS1, and so on and so forth. You get the pattern. So let's jump into, let's go and create our SVI for VLAN 5. We're going to do IP add 10.10.5.30, not 31. We're going to do 32. Not 32, we're going to do 34 with a /27 mask, so .224. We're gonna do standby version 2, and then standby 5, because as I said in the previous video, why not make your group number the same number as your VLAN ID if you have the same available numbers from 0 to 4095 for your group ID as you do for your VLAN ID. Just makes sense to me. You do your thing, I do my thing. So standby 5 IP, and our virtual gateway is going to be 10.10.5.33. And then we're going to do standby 5 priority. We want DS1 to be our active router for VLAN 5, so we're going to do 110. And I do not believe I am missing anything, but we'll do contextual help just to make sure. Got the gateway, got the priority. That's all we really need here. Jump into VLAN, or create the S5 for VLAN 110. Same deal, we're going to do IP add 10.10.10. We're going to do 3. Effectively, I could do 2, but I'm trying to, make a pattern here. So .3 is going to be my standbys, .2s are going to be my actives, and then obviously .1 is going to be the, or whatever the first IP in the subnet is going to be the gateway. So IP add 10.10.10.3. This is a /24 mask, keeping it simple. We're going to do standby version 2, standby 1110, IP 10.10.10 or 110.1 is not within the subnet. Oh, that's my bad. So let's change our IP to, once again, I'm not perfect, so I'm doing command recall to go back up to the IP that I was adding to VLAN 110. We just need to make that 10.10.110.3, not 10.10.10.3. Okay. So we should be good on our virtual gateway then, but I'm going to go ahead and resend it. And then standby 110 priority. Remember, DS1 is going to be our standby router. So standby 110 priority 90. Alright, let's jump into creating our SVI for VLAN 120. We're going to do IP add 10.10.120 this time, .2.255.255.255.0, standby version 2, standby 120 IP 10.10.10 or 120, my bad, .1. Standby 120 priority 110. It's good for 120. Let's jump into VLAN 100 for our admin VLAN. IP add 10.10.100.3 with a /24. We're gonna do standby version 2. This is gonna be pretty repetitive, so may not call out every single command at this point in time because we're kind of doing the same thing over and over from here on. So standby IP 10.10.100.1, standby 100 priority. We did 110 on 120, so let's do 90 on 100. So that's pretty much the gist for DS1 for the moment. We'll get to circle back and do a few things later on, but taking it step by step, let's jump into create the VLANs for DS2. Name it management. VLAN 110. Name is going to be users. VLAN 120. Name printers. VLAN 100. Name admins. Interface VLAN 5, IP add 10.10.5.35 with a /27. standby version 2, standby 5 IP 10.10.5.33, standby 5 priority is going to be 90. That's pretty much it for VLAN 5. Jump into 110. We're going to do IP add 10.10.110. Gotta remember that this time. This is going to be the active router for VLAN 110, so we're going to do .2 with a /24 mask. Standby version 2. Standby 110 IP is going to be 10.10.110.1. I'm just going to do command recall. Tired of typing things out. Priority. It's going to be our active router. Yeah, active router for VLAN 110, so priority 110. Interface VLAN 120. We're going to do IP add 10.10.120. This is the standby, so .3 /24 mask. Standby version 2. Standby 120 IP 10.10.120.1. Standby 120 priority. See, this is going to be the standby router, so 90. And interface VLAN 100 IP add 10.10.100. It's going to be active, so .2. And then standby version 2. Standby 100 IP 10.10.100.1. Standby 100 priority. This is going to be active, so 110. All right. All good there. Let's check our standby. Now, being that we built them all out on DS1, as we saw in the last video, I had to go in and manually shut one of the interfaces to force the active or the standby router on spine switch 2 that I wanted to be the active router. I had to go shut VLAN 10 on spine switch 1 to force SS2 on VLAN 10 to become the active router. So let's see if we have to do the same thing on this side. I'm in DS2, I'm going to do show standby. Nope, show standby. So we got, okay, DS2 is VLAN 5 or group 5 is in standby. VLAN 10, we want it to be active, but it's in standby. 120, it's in standby, and 100, we want it to be active, but it's in standby. So let's shut 110 and 100 on DS1. Interface VLAN 110, shut, and interface VLAN 100, shut. Next time we go around, we're going to just do an interface range on the VLAN. So interface range VLAN, and then you just comma separate it. So it should be like 110, maybe space. No. Alright, well I guess Packet Tracer doesn't like that. 100. Nope, I guess we can't do that then. Move it on to move on. Packet Tracer is not like a perfect product. It's an emulator, and it does what it needs to do for CCNA and arguably Encore to a certain degree. But if you have the ability to get real gear or use CML, it's honestly what I recommend. Alright, so VLAN 110 is now in the active state on DS2, and so is VLAN 100. 120 still in standby, and 5 is in standby. So let's go ahead and turn back on those interfaces. Interface VLAN 100, no shut. And interface VLAN 110, no shut. And that should be good. We'll give it a second and just make sure we check our work. Show standby. Still active. Let's go back to DS1. They're probably like in the listening speak stage still, so yep. See, 110 is still in speak. And okay, well 100's in standby, so probably do another run. Yep, 110's in standby. 100's in standby. 120 still in active. 5 is still inactive, so we are good there. Next thing we need to do is the subnets that we just created for these different VLANs. We need to advertise that in EIGRP. Previously mentioned in the last video, you can either advertise the subnets into EIGRP itself, or you can redistribute them as connected routes. That's what I prefer to do in this scenario, so I'm going to do exactly that. So router EIGRP 10, redistribute connected. I was on DS1. So let's do the same thing on DS2. Router EIGRP 10, redistribute connected. All right, all should be good there. Let's jump on over to our access switch. Let's get this guy caught up. No IP domain. Lookup. No logging console. Host. Just AS1. Alright. So we only need to create one SVI, and that's for VLAN 5, but we're going to also make sure that we add our other VLANs for 110, 120, and 100, because we're going to make access ports with those. So just jump straight into creating the VLANs. So if you are good with VTP, we could have done VTP where we assigned a VTP server and made the rest of them clients, and they would just automatically update with the VLAN database. We're not doing that in this lab. Maybe I'll do a future lab, but just know that that's an option here, rather than having to type out every single VLAN on every single switch. But also in a production network, you got to be careful with that kind of stuff, because it can be a pretty powerful tool in the wrong hands, you know. Name users, VLAN 120, name printers, VLAN 100, name admins. Okay. So what ports we got here? I think this is gig 01, gig 02 scenario. Indeed it is. So let's do an interface range. Gig 1/0/2 to 3. Guess we gotta back out. Interface range. Now we gotta go to global config. Interface range. Gig 10/2 to 3. Duh. 0/2. Interface range command rejected. All right, it's been a long day. It's been a long day. Switch port mode trunk. So we just made our upstream links on AS1, both trunks. Next thing we need to do is jump into or create our VLAN 5 SVI. And so virtual gateway is 10.10.5.33. 34 is DS1. 35 should be DS2. 35 is DS2. So we're going to make AS1 36, so 10.10.5.36 with a /27 mask. Alright, now make sure I don't put the wrong gateway in here this time, but we're going to go ahead and add our gateway, default gateway, 10.10.5.33. And let's see if we can ping all the way to the DHCP server. So ping 10.10.10.10. And we're good. We are good. So the last thing we need to do here, that we should need to do here, is just configure our access ports in correlation with the devices that we're working with here. So our printer port, which is on F02, it's going to go in, it's going to be an access port, static access port, switch port. Let's do switch port mode access first. And switch port access VLAN, what is that, 120? Alright. And then one more thing. Spanning tree port fast, so we can cut past the listening or learning phase. And then F01. Switch port mode access, switch port access VLAN. Users are in 110. Send that spanning tree port fast. And then this should be F03 for the admin. Come on. Yep, F03. Interface F/0/3. Switch port mode access. Switch port access. VLAN 100. Spanning tree port fast. Alright. Now let's see if I did everything right. So ultimately the goal here was that we were going to configure our office network to be able to communicate with our data center side as if we were building up a brand new network, right? And the whole intent was that our office users, our printers, and our admins over sitting in their office need to be able to reach out to the DHCP server to pull DHCP addresses. So let's see if we were successful in that approach. So config. Let's turn on DHCP. I'm going to come back to the printer. Printer's going to probably take a little bit to load. Let's go to our laptop. That's already set for DHCP. Let's do an IP config 169. See if we do release and then renew. We're going to learn something here in a second. So the reason why we can't reach out to the DHCP server, or the devices can't pull a DHCP server, is because whenever you reach out to a service in this type of scenario that's in a remote network or in a different network, you have to add what's called an IP helper address to point your devices in that direction to pull that service, so like DNS, DHCP. So we're going to jump into our SVIs over here. So interface VLAN 30, let's start with that, or not 30. Interface VLAN 110, we'll start with that. And we'll do IP helper address. It's going to be 10.10.10.10. Do the same thing on DS2. Interface VLAN 110, IP helper address 10.10.10.10. Let's see if that helped us out any. So this is just for the user VLAN. We'll see what happens now. Renew. And we were able to pull an IP. Notice how that helper address was the fix action for that. So let's go ahead and do that for the printer. VLAN and the admin VLAN. So interface VLAN 120. Let's just do that command recall, because it's going to be the same IP, because there's only one server with that IP. And we're going to jump into interface VLAN 100. Same deal there, command recall. Jump on over to DS2. Interface VLAN 100. IP help. Let's do command recall. I don't feel like typing that out. And then interface VLAN 120. Command recall. Save our config. And let's see how we fared. There we go. Printer pool 10.10.120.10/24 mask. Admin PC, what we got? What we got? I don't even think we didn't even set it for GHP yet, so. But there we go. Pulled a IP in the 10.100 range, so we are good to go there. Now, do we need to test ping to the DHCP server? No, because we just verified that our devices on the far end in the office can reach out to the DHCP server because they just pulled IP addresses from the DHCP server. But, you know, let's just do it for the sake of it. You know, test from the admin machine that we can ping all the way out to the DHCP server. We already know we can because, like I said, we pulled the service, but let's just show that we can. 10.10. There we go. Cool beans. Laptop 2. Ping 10.10.10.10. So something to take away from this, as I mentioned, is that if you ever have a DHCP server that sits in another network, another broadcast domain, just make sure that you add that IP helper address to whatever SVI that your device is sitting in, if it's trying to pull a DHCP address. So that's pretty much going to conclude this video for day 2. That was task 6. Make sure that our laptops and printers can pull DHCP addresses. So in the next video, we're going to play around with hardening devices. Like I said in the day 1 video, I have not tried this other than like ACLs and applying the ACLs to VTY lines. I haven't seen like what can we apply for AAA? Like, can we enforce a local admin login? Can we can we apply AAA statements? What type of ACLs can we apply to this thing? You know, let's just play around with hardening our devices so we can practice some type of level of network security in our environment. So tune in for the next video on that for our day 3 task, and thank you for watching.